Dr. Babasaheb Ambedkar Open University.
Hello students, in the lecture series of course Cloud Infrastructure and Services, you have already learned the first unit, that is very basic introduction of cloud computing. Now in today's session, we will discuss next unit, that is unit 2, in which we will study cloud infrastructure as well as few other infrastructure. So why these other structures are required? Because whatever the infrastructure that are available or that can be used for the cloud computing, some way or other way, these other infrastructure, or you can say that these other architectures, they are the base for this cloud infrastructure. So today we are starting with the unit 2. So agenda of the today's session, we will see a quick recap of cloud computing. Then after we will discuss computer layer architecture. Then other architecture we will include peer-to-peer architecture as well as client-server architecture. Learning objectives. So after studying this unit, you should able to understand the basic layered architecture of cloud, and you can explore the various other architectures as we have already discussed, peer-to-peer architecture as well as client-server architecture. We will also compare multiple architectures, so you will get more idea how those architectures that can be used as a base for cloud infrastructure, or you can say that the cloud architecture. Now the quick recap for the cloud computing. So it is one of the most demanding technologies of the current time and is giving a new shape to every organization by providing on-demand virtualization services, or you can say that the resources. So as you already aware, small to medium organization or medium to large organization, every organization nowadays required to share some information, required to fetch some information from remote places, from any other locations. So any organization that can fetch the information or access it from anywhere at any time with the help of internet by using the concept called cloud computing. It refers to delivering of computing services. Now which are the computing services that can be used? So basically you can use servers, storage, database, networking, software, analytics or intelligence, any kind of services or any kind of document or any kind of information that you can able to access with the help of cloud computing over the internet with pay-you-as-you-go pricing. Now it is also called internet-based computing, where users get resources and services through the internet. This offers benefit like faster innovation, flexible resources and cost savings. The data that is stored can be file, image, document or any other storable documents. Rather than buying, owning or maintaining some very costliest infrastructure, or you can say the resources, it is advisable to use whatever the computing power. It may be processing power, it may be memory, it may be storage, or it may be in the form of database or any other resources. So it is not required to maintain at your end, at user end, but you can use some of the services, some of the cloud service providers like AWS or Google platforms or Google Cloud platforms. They are providing such services as per your requirement. So you have to pay only for those services which you are requiring. That is the biggest advantage of cloud computing. Now according to International Standard Organization as well as the NIST, National Information and Scientific Technology, cloud computing is the paradigm for enabling network access to the scalable and elastic pool of shareable physical or virtual resources with self-respect provisioning and administrating on demand. So whatever you are demanding, you can get the resources as you have to pay. So whatever you are requiring, for only those you have to pay. That is the biggest advantage of cloud computing or cloud services. Now we will discuss cloud layer architecture. So basically cloud layer architecture can be viewed as a collection of hosted services over the internet. As you already aware the concept of cloud computing, basically you are requiring internet, and whatever the infrastructure or whatever the services, it may be any software, it may be any hardware, you can able to access from any location based on whatever the service provided that you are choosing. Now all those physical manifestation of cloud computing can be arranged into the layer that encompasses anything from software system to the hardware appliances. That means what? Suppose you want to use any hardware devices, you want to use some of the resources, or suppose you want to use any software, all those that can be separated in some layer architecture. So the cloud layer architecture itself, whatever the services or the resources that can be provided through this platform, all that can be considered on a separate layers. So you can also see in the figure or in the diagram, these basically 4 layers that can be used as an architecture layers of the cloud. First is physical layer, that is infrastructure. Second one is virtualization layer. Third one is service layer, and fourth one is application layer. Now we can observe the diagram. First, that is infrastructure or physical layer. What is the meaning of infrastructure or physical layer? Suppose you want to use some of the hardware devices, or say for example, you can consider the services of Amazon, that is AWS services, or you can consider the services of Google platform. So whatever the resources, you can say that the hardware resources or the infrastructure or the data center server that are located on different geographic locations, that are all considering under this layer, that is physical layer. So you can access those layer, or you can access those infrastructure with this first layer. Now mind well, cloud computing follows a layer architecture where each layer provides services to the layer above it. So whatever the layer at the below, they can access whatever the services from the above layer. So we have already discussed the first layer, that is physical layer, in which all the hardware resources that can be used, that can be allocated here in this layer. Then after virtualization layer, you already aware with the concept of virtualization. That means suppose you are not having sufficient resources. Resource can be of anything. It may be processing power, it may be memory, it may be storage, it may be any document. In that case, what happen? You are having some virtual platform by which you can access whatever the requirement devices. So here virtualization layer that will provide you some abstract physical resources. The very common example, that is hypervisor, that is VMware or such kind of software that will provide that kind of platform for virtualization. Then after service layers, so as in the previous session you have already learned about basic service providing by the cloud, that is SaaS, that is software as a service, platform as a service, and infrastructure as a service. In infrastructure as a service, you are just using whatever the infrastructure from different providers. PaaS, that is platform as a service. Here the developer will get platform for the creation of application, for the development of application. It is not required to bother about any kind of software, any kind of platform which are required to create any application. So normally developers are using these PaaS services. SaaS, that is software as a service. Say for example, you want to access some software, say for example Microsoft Office or Office 365. In that case, they are providing this software to the user. So this way you are using different kind of services by using this layer. And the fourth layer, that is application layer, you can say that it is working as a front end, or where the user will interact with this layer. So if user demanding some of the services, so that demand that can be proposed by using this layer, that is application, you can say that the interface with the user. So these are the all basic layer for cloud layer architecture. We will deal with each and every layer in detail. Now you can see physical layer or the infrastructure in more detailed way. You can observe here in the figure also. So basically cloud computer architecture, first is cloud infrastructure, that is front end. You can say that whatever the resources available for shareable basis, based on whatever the money that you are paying for that particular platforms, all those resources that are available here in this layer, that is cloud infrastructure layer. In between there is a platform, you can say that the internet, because without internet you cannot able to access any kind of these services, any kind of these resources. Then after the main thing, cloud layer architecture, that are application, services and storage. All these layers that are separately work together, and whenever the user required some of the resources, they are dealing with the user requirement according to whatever the terms and condition. So first is physical layer, data center, server, storage devices, network hardware, all are represented in the form of physical layer. You can take the example Amazon AWS data centers located worldwide, or you can say any other Google platform, Google Cloud platforms which are available in different locations. Second layer is virtualization layer, that abstracts the hardware into virtual machines and the resources. Say for example, you are not having sufficient hardware requirements, say for example you are not having sufficient storage capacity hard disk, or you are not having sufficient memory. In that case, you are using virtualization concept, and you can use any other devices or any other resources that can be provided by the cloud platform. Say for example, VMware, Hyper-V, AWS EC2, that is elastic computing instances, that are the examples of this virtualization layer. Third layer, that is service layer. As you are already aware, basic three types of services: infrastructure as a service, platform as a service and software as a service. So all three that can be accessible with the help of this layer. Then after application layer, whatever the end user or the user can access all those services with the help of this layer. So by using this layer, user can interact with all previous layers with the mediation of internet. You can say the example Netflix, you are using videos, you are watching the movies on the Netflix platform. So that is the interaction in the application layer by the user, and the Netflix different server or different location, whatever the videos or the files that are available, that can be streaming at your end. Why layered architecture? So here different features, so you can understand why the layer architecture is required. Because of first is scalability, so each layer can scale independently. So whatever the number of resources that can be increased, whatever the number of needs of the user that will be increased, you can change the requirement, whether you can increase, whether you can decrease the scalability of each and every layer. That is very useful feature for this cloud computing architecture. Flexibility, according to your requirement, if you are requiring some infrastructure, then you have to pay only for infrastructure. If you are requiring some software based services, in that case you can use only those software. If you are requiring some infrastructure, software or the platform, in that case you have to pay only for those. So this bifurcation that is available, that's why it is flexible. Then after abstraction, so complexity of hardware and virtualization is hidden from the end user. The same, suppose some of the software that you are using or you are operating your mobile, so at that time you are just operating whatever the complexity that can be hide with the user. Same way here, you have to access whatever the infrastructure or whatever the services or the platform from the cloud, but whatever the hidden complexities that can be not seen by the user, so you can say that it is abstract. Cost efficiency, or you can say that effectively, because if the user wants those resources or those amount of resources at their end, in that case it is very costlier. So instead of that, user can access only those resources for specific limit of time. So that is cost effective or efficient. And reliability, multiple layers provide fault tolerance. In some cases, suppose some error will occur, your continuation, if you are not able to access some of the services, then it is not only the one platform by which you are using those services, because at the cloud platform providers or the cloud services, that can be multiply available on different platforms with multiple locations. So fault tolerance, that is negligible, and you can access whatever the devices you are requiring, whatever the services you want to use, that can be available with you in the layered architecture. Now we can take one simple example, a real life example, so you can get more idea how these 4 layers that can be used in cloud architecture. So first is physical layer, we are taking the example of Netflix. So AWS data centers running servers. So whatever the requirement of infrastructure or the resources that are available in the physical layer, at say for example you are using the AWS services, so multiple data centers at different geographic locations that are available. Virtualization layer, that is AWS hypervisor that running various virtual machines to host Netflix workloads. So if for example multiple users are there, sometimes the user may increase, so still the Netflix services, they are smoothly running. Why? Because whatever the main data store or the data center that are distributed and multiple virtual machines that can be used. So separately each and every machine that will understand that required resources that are available with that particular machine, and it can be easily available to the particular user. Service layer, Netflix uses AWS EC2, that is infrastructure as a service, and AWS RDS. So elastic computing and relational database services, that is platform as a service, both are merged together in a service layer. In application layer, the Netflix app or the website that you are using to watch movies. So we have taken this example AWS and how this Netflix that can be accessed, all these services of the cloud that you can easily understand with this help of this real life example. Now if we are talking about some other architectures, so you can understand peer-to-peer as well as client-server architecture we will also learn. So in peer-to-peer architecture, every computer, you can say that every node or every peer acts both as a client and a server. So here there is not a single server, not a single client, all are having with the same capacity, all are working with the same capacity. It is the decentralized control and no centralized authority will be there, and resource sharing, as each peer can share files, resources and services with others. Scalable, as more peers are improved resource availability. So in this network, or you can say that in this architecture, more amount of node, more amount of computers that are joined or that are increased, more amount of resources you will get, because each and every node resources are shared. There is no centralization control, all are as a decentral platform. So each one can use other resources or share resources. Examples, so BitTorrent, you already aware, suppose you are downloading some of the movie or some of the software from the BitTorrent or platform. In that case what happened, the files are located on multiple locations, multiple servers, you can say that the multiple nodes. You can access multiple part of the files at the one end, at the user end. Then Skype, in which video call or voice call communication that can be done with the help of this peer-to-peer. Then blockchain and cryptocurrencies, the very demanding currency, that is Bitcoin. So here each and every node that can approve for validity. So here decentralization model that can be used in peer-to-peer, because if you want to approve, if you want to verify whatever the details that you are uploading on the network, that can be approved by each and every node on the peer-to-peer, that is decentralization system. Now you can, another example, if you can take the example of potluck dinner. So everyone brings their own food, there is no separate kitchen concept, that means there is no separate server, there is no individual server available, and anyone can access anyone's resource, or you can say that anyone can use or anyone can eat whatever the food of others. So this way, these are the real life examples of peer-to-peer. Now the second is client server architecture. Here you can observe in the figure, there is only single server, and whatever the other computers, or you can say the other node or other devices, they are working as clients. So here it is centralized. If you are taking the difference of peer-to-peer and client server, so in peer-to-peer it is decentralized network, but here in client server it is centralized network and centralized control, as a central server provides services to the multiple clients and it will manage all the requests. So what happens when the client or the whatever the node that can demand for something, or you can say that the request something, and the server that responds according to the request. So it is easier to manage compared to the P2P, because you have to manage only the server, one server, but in peer-to-peer you have to manage multiple nodes. Examples, you can take email server, file server. So Gmail client, that will be considering as Gmail that you are using for accessing your inbox, that is the Gmail client, and where all those mail are located, that is the Gmail server. So here you are requesting for any mail, and Google Gmail server that will accept the request, and accordingly it will respond. Same way banking app, suppose you are doing mobile banking or internet banking, so your mobile device you are accessing whatever with the some app or any browser, so you are a client, and whatever the transactions or whatever the operations that can be performed on the bank server, so there is one server. Then after web applications, you can use any of the application, any of the website. Say for example, you are using some social media website, Facebook or the Google. In that case, what happened? You are just putting some request on the browser, and whatever the response you are getting, that is from the server. Another real life example you can take here for client server architecture, that is, think about the library. So student can request the books. Here the role of librarian, that is the central server. Without his or her permission, you cannot exchange the book with the other student. So the student do not share the books directly with each other. All requests go through the librarian. So this way you can understand the client server architecture. Now here it is the comparison. So control for peer-to-peer, that is decentralized, and for client server it is centralized. Resource sharing, peers share the resources equally, while in client server architecture only server provides resources. So anything client requires, the client request for that particular resource for the server. Examples, BitTorrent, blockchain, as we have already discussed, and in client server, Gmail, Facebook, banking application, these are the real life examples. In terms of cost, it is low in peer-to-peer because uses peer resources, whatever the resources that are shareable among all the clients, all the nodes. But here, whatever the resources that are available on the server only, and according to the requirement or the request of the client, that resources will be provided. So maintenance, that is more here in the client server architecture. Scalability, it is good in peer-to-peer. Why? If the number of nodes or number of computers that will be increased, accordingly the sharing ratio or resources that can be increased. And in client server it is limited because the server limited by the server capacity. As the server capacity, accordingly only the functionality that will be performed. Reliability, so it is tolerant but inconsistent, because suppose one node fails, you can access another node, right? But whatever the information, whatever the resources that you want to manage in peer-to-peer, that is quite inconsistent because multiple copies are there on multiple devices. While in the client server, it is consistent because the central authority is with the server. So whatever the data, whatever the information, whatever the resource that is available with the server, and a single copy is available. But there is one disadvantage: if the server fails, the whole architecture or whole the system will fail. Now let us conclude our session here. So we have discussed in today's session cloud computing. We have revised few of the fundamentals of cloud computing. We have also discussed layered architecture, in which 4 architecture we have discussed in detailed manner. We have also discussed peer-to-peer architecture as well as client server architecture. In next subsequent session, we will discuss in detail grid computing, how it differs from the cloud computing, and we will see the most important concept in cloud computing or cloud infrastructure, that is virtualization or server virtualization. Thank you. Happy learning.